Hi, my name is Kurt Regner. I work in the School of Life Sciences. My job is different than the other two speakers. I predominantly teach freshman and sophomore biology majors and biochemistry majors, and then the large number of non-majors that need to take a science with a lab. And that encompasses just about every major on campus. Probably the largest segment of that is students who want to go into the allied health professions. So the first question is, what are the biggest ideas or the biggest issues in our field? Well, for me, that would be teaching evolution, teaching cell physiology, and then trying to connect both of those to genetics. And those probably have been the same three big ideas in biology for the last 100 years. Okay, so how do we attempt to tackle that or take that on? So when I started here 12 years ago, colleagues would give me the textbook, and all textbooks come with pre-programmed test banks, and those test banks tend to just ask factual type questions, and I have a number of examples of those, and those are pretty easy, and those reinforce rote memorization. And then I would say about 5 or 6 years ago, I just started writing my own questions, and I also discovered something called concept inventory tests. So every scientific discipline, and this is probably true for the social sciences and the non-science fields, committees identify the concepts that they want all the graduates to have, and then they produce questions to test those. And those questions generally require the student to apply the information. And so I employ that technique. And the students have very hard times with those types of questions. In the fact-based question, the success rate is usually around 75 to 80%. In the sort of concept type question, the success rate is around 50% or sometimes even lower. That's somewhat disappointing. We try to prepare the students for that by using these in-class participation systems such as iClicker or Top Hat, and many of you have probably tried to use those. So that's my approach in the 100 and 200 level classes. I also teach some 300 level classes, and not only do I use the concept questions, but other techniques I use is I ask them to do some outside reading, and that could be a scientific paper, or they need to visit a website. And again, test questions we'll query them on this information. Again, it could be fact-based, or again, they could have to understand the underlying concept. And then something we haven't implemented yet, but we're going to start in the fall, is that in some classes, the students will be required to read 4 scientific papers from the same lab group over a period of time. So the lab, let's say, is investigating how a yeast or a bacterium metabolizes a particular compound. So the first paper they'll write may be 10 or 15 or even 20 years old when the science is just getting started. And then they'll read papers maybe every 5 years to the most recent one. And there they'll be able to see the process of science within a particular system. And then you try to relate that to concepts, or you do your best to relating that to concepts in the class. And then the last aspect to encourage critical thinking is in the fall, 2 biology colleagues and I are going to initiate the first classroom-based research experience. So this class will address a specific research question. Our class deals with bacteriophage biology. Bacteriophages are viruses that infect bacteria. They're completely harmless to humans. We can bring them into the laboratory, and they're a great model system for viruses and cellular processes that all biology students should know. So anyway, that's my story. Happy to answer any questions. And again, I apologize for not bringing the correct format.
We can share those out afterwards. Thank you.
Thanks.
All right, so many thanks to our panelists.